Okay, now we're going to talk about limits at infinity when the x is headed towards either positive or negative infinity of a function. Okay, the first thing we're going to talk about is polynomial functions. And essentially, since polynomial functions are fully continuous, you can just look at their parent graph for end behaviors. So something like this, as the limit as x approaches negative infinity, a negative x cubed. Well, remember, positive x cubed looks like this. So a negative x cubed looks like this. And if we're looking at positive infinity, negative infinity, if we're headed in this direction, what is the end behavior doing? It's headed towards positive infinity. Okay, the next one that we're going to be looking at is what happens when the rest of them will be rational functions. So what happens when the exponent, the highest exponent in the numerator is lower than the highest exponent in the denominator? Automatically, the answer is 0. When the x in the numerator, the highest x in the numerator, is the same as the x in the denominator, then whatever's attached to whatever's the coefficient of those two x's, that's what the limit will be. That's what the height of that function will be, the ratio between a and b, so a over b. So if you, anyway, I'll do an example in a minute. And then our final example is when the x is higher in the numerator than in the denominator. Technically, a limit doesn't exist, but actually what we're looking for is what is the end behavior of that graph. And this is one of those weird graphs where there's going to be possibly, well, they're horizontal, maybe a vertical, but also a slant asymptote, and the graphs will look something like that. They will be angled. All right, let's get started. All right, so I showed you the polynomial. So now we have when x is lower in the numerator than in the denominator, and you're headed towards either positive infinity or negative infinity. So it looks something like that. And I said the answer is always going to be 0. And if you were to take this function and type it into Desmos or another graphing calculator, this is the graph, but what you have to pay attention to is what are the y's doing as we head off to infinity? Well, we're getting really, really close to 0 without ever touching it. That's what the height is doing. The height is getting very close to 0. All right, now what do we do when, when the degree in the numerator is the same? You're going to be focused on whatever's attached to the variable x, and that is what the answer is going to be. So let's give an example. So if you have a 2x squared plus x subtract 1, that function, over 3x squared plus 2x plus 1, that function, we're going to be looking at the highest degree, which is the x squareds. They're the same. So we just look at the a and the b, and that is the height. And then I type that into a graphing device, and then look at, you can't really see that 1 is right here, but there is this invisible asymptote right there at 2/3, and that height of the function of that graph is getting very, very close to 2/3. And then the final example is when the degree in the numerator is higher than the degree in the denominator. Technically, it doesn't exist. The limit does not exist, but we want to know where is the graph headed to. It doesn't exist because the left and the right are not going to agree. So let's look at an example. X to the fourth plus x plus 1 over x cubed, subtract x, subtract 2. And because this is higher, this highest degree is higher than this highest degree, technically they do not exist because the behavior on both sides won't agree. But what is the end behavior as we're headed towards positive infinity? See, this is why it doesn't exist, because this side is going this way, this side is going that way. The two don't agree, so it does not exist. But look at what's happening with this graph as we're headed towards positive infinity. The y values are headed straight up, also towards positive infinity. Okay, so let's do a recap. When you're taking limits at infinity, meaning the x value is headed towards positive or negative infinity, what are the y values doing? Well, if it's a polynomial, you can just use your information, what you know about parent graphs, and figure it out that way. Now remember, polynomials, if there's a negative sign in front, these things are going to be flipped, so you do have to consider that. Okay, then the trick was when, for the rational functions, when the degree in the numerator is lower than the degree in the denominator, your limit answer will always equal 0. When the degrees are the same in the numerator and the denominator for the highest exponent, you're going to look at the coefficients attached to those two, and that's what the answer will be. And then when the degree in the denominator in the numerator is higher than the denominator, the technical answer is the limit doesn't exist, but you're going to think about the end behavior of the graph, think about where you're headed, and then look at what the y's are doing. As you're headed towards positive infinity, are the y's going this way or the y's going that way? And then that's what you put for your answer. And I think that's it. We'll be practicing those in class. They might trip you up a little bit, but if you're paying attention to these kind of shortcuts or tips, you should do fine.